As the final part of our course on DHTs, let's show that DHTs can be used as an infrastructure for building applications. So when we build large-scale distributed applications, we can use our DHT as their base platform for running it. It gives us the basic services, storage, replication, transactions, and broadcasts. We can build a scalable, decentralized application on top of it. In the Selfman project, we actually built a distributed Wikipedia, which I'll show in a few minutes. So the idea is to start with a component model in similar way to which we defined algorithms in this course. So services and applications will be concurrent components, and we make a layered structure of these components, and the application can be built on top of this. So we built several applications using this, and typical application infrastructures that you can find are inspired by the same kind of approach. So here, let's take a look at our DHT. So here is a monolithic DHT, but in fact, there is stuff inside there. If you look at it, there is at least the following things. There's the ring, there's a periodic stabilization, which I didn't talk about, which complements the correction on use. There's a router, topology maintenance. There is other things, ring merger, ring unification, when we have network partitions, things that I didn't talk about, which exist in the real systems. We have a failure detector, we have network, we have timer. And in fact, in the Selfman project, we built a number of services on top of the DHT infrastructure. So we have, you saw that we can do broadcast. We also have a Paxos, which is a consensus algorithm. We have replication. We have gradient topology support for super peers. We have the failure detector. We have a transaction manager. We have aggregation, so basically doing computations. So we have a number of things that are added there that are basic services that you can use to build applications. And we built two key value stores, one of them called Scalaris and the other one called BeerNet in the project Selfman. Both of them provide transactions on top of the DHT, strong consistency on top of this DHT using Paxos consensus. They are scalable to hundreds of nodes. We've tested 200 nodes. And in fact, Scalaris won a prize. It won first prize in IEEE Scalable Computing Challenge in 2008. So this is an example of a scalable application infrastructure. So let me explain this. So we did one application called a dtransdraw, which is a collaborative drawing application on BeerNet. But let me not talk about that one. Let me just talk about the distributed Wikipedia, which is the application we did on Scalaris. So if you look at Wikipedia, Wikipedia is an extremely popular web application. If you look, this is in 2008, Wikipedia was number 8 in popularity, and today in 2019 still extremely popular. In those days, it was handling 50,000 requests per second. 95% of those requests are handled by proxies. Only 2,000 requests per second hit the actual backend database. So the backend database has to support that. So the Wikipedia, what is the architecture of the real Wikipedia? So here we have the actual internet. We have proxies here, the squid proxies. We have web servers. We have the actual database backend, which is using MySQL, and we have other kinds of support systems. So we have a lot of proxies which are handling most of the queries. But the backend database is what we will concentrate on. So Wikipedia is using a SQL database model with SQL tables, whereas Scalaris is not doing SQL. It's a key value store built on the distributed hash table. So basically we will map the SQL database onto the key value store. So the relations in the Wikipedia SQL, we map them to key value pairs. So on the left we have the keys, and on the right we have the values. So we have for each title of the page, we have the versions of the page, we have the categories, and we have the list of titles of the page corresponding to the category. We also have the links on the page. For each page title, we have another list of titles. So then we can use this to build transactions that perform the Wikipedia operations. So for example, here is an update page operation. We have a string, the new value of the page, the old version of the page, the title of the page, sorry, the new text for the page. We create a transaction. Scalaris supports transactions. I didn't explain how that works, but the transaction can be built as a service on top of DHT in the same way as broadcast is built, using the DHT structure, building a transaction manager, and doing consensus for the commit or abort. So we read the page, we check the version in case we have concurrent updates, and we write the new content. So this is an example of how the update page is done. So the new text, we update the categories, and we commit the transaction. So this is built using the Scalaris architecture. So Scalaris uses a variation on the distributed carry search on Chord called Chord Sharp, and we have also extended this with a renderer and an interface to Erlang. Scalaris is actually written in Erlang. We also have a load balancer. So we basically have built this top end on top of the Scalaris. We have the HTTP part for the web page and the Chord Sharp backend. So here's an example of a page coming from the Scalaris. So this is Wikipedia in the Bavarian local dialect, which is kind of resembling German a little bit. So in 2008, there was an IEEE scale challenge. We made live demos of Wikipedia in Bavarian and in simple English, browsing, editing, also category pages. We made 2 deployments of the Wikipedia on Scalaris, one on Planet Lab. So Planet Lab is a worldwide distributed infrastructure for experimenting with applications, with lots of small nodes maintained by universities all over the world, which is highly unreliable. So if your application runs on Planet Lab, it's actually pretty good. We also had a cluster in Berlin. So Berlin, this is in the Zuse Institute, so the supercomputing center in Berlin, where we made a cluster, a large cluster of 320 nodes running the Wikipedia on Scalaris. And this system won the Technical Committee on Scalable Computing Scale Award for 2008, and this is a picture of the plaque that was given as the prize for this award, to show that this system is actually able to do, was able to scale up. So this is a practical platform for large, robust, scalable distributed applications. So concluding, we can see that DHTs are actually a practical base to build scalable, decentralized applications that are efficient. So it has efficient communication and storage. It has important services. And we showed this with 2 implementations, Scalaris and BeerNet. So this is part of the Selfman project, where we built these systems using Selfman. And in fact, there are many distributed application structures in the world, done by commercial systems. Many of these are using architectures which are similar to this one. So the DHT, the self-maintaining architecture, is an important way of building large-scale, scalable, efficient, dynamic distributed applications. Thank you.